Good afternoon. Today I will tell you about a rapid and innovative method to identify possible frauds in terms of oenological adjuvant product use. And we will focus on chitosan, which is a matrix which, as you saw, is a linear polysaccharide composed of two kinds of glucosamine and acetyl D-glucosamine and D-glucosamine linked by beta 1 to 4 bonds. Chitosan is used in several domains, in agriculture, in industry, for the synthesis of polyurethane, in medicine as an antibacterial agent, and in winemaking. And we will consider chitosan in that sector today in terms of its microbiological control effect. It reduces sulphites, it has an antioxidant property, it can be used for clarification purposes, and so on and so forth. What about its origin? Normally, it comes from the exoskeleton of crustaceans or insects. So what we find in known winemaking sectors normally originates from there. Chitin is extracted, and then after a deacetylation process, it is transformed into chitosan. As we saw in the previous presentation, chitosan is not permitted in winemaking. It was banned by OIV in that there might be residues of a protein, which is troponin, which might cause allergies. And for this reason, we can only use in winemaking chitosan, which comes from fungi. So the one derived from crustaceans is forbidden, while it can be used if isolated from the mycelia of fungi. The methods entail three different ways to identify the fungal origin of chitosan. The residual glucan that has to be in excess of 2%, and this is measured spectrophotometrically. Then viscosity is used, and it is a 1% solution, 1% acetic acid, less than 15 cp, and settled density must exceed 0.7 grams per cubic centimeter. These three methods are very complex. For instance, in terms of settled density, we do not even have a device on the market. You have to build your own in the laboratory. These methods entail a very long time, and oftentimes you receive an ambiguous response, an answer, because that is linked to the preparation itself. For this reason, we thought that we should test the isotopic method in order to develop a rapid and innovative method that can identify rapidly the fungal origin of chitosan. We isolated samples from crustacean exoskeletons and compared and contrasted them with real samples from fungi. We use the stable isotope ratio analysis approach, which is used also in other sectors in winemaking, especially when identifying the addition of sugars and when in order to ascertain whether a water addition was performed. We talk about isotopes, that is atoms with the same number of protons and electrons, but different numbers of neutrons, so different masses. For instance, for carbon, we measure carbon 12 and carbon 13, which are brothers of the famous carbon 14, which is not used for this type of analysis, though. The analysis entails that you measure the ratio in between the heavy isotope, carbon 13, and the light isotope, which is carbon 12. And that is expressed in relation to international standards of reference. You see in the box that normally in nature, you have a higher presence of the lighter isotope, 99% in the case of carbon 12, while carbon 13 is only 1% approximately in nature. Carbon changes depending on a number of factors, and especially the plant origin. We see that if we have a C3 plant, as is the case with vines or fruit trees, there the range is typical and it is lower. We are in the negative range, -33 and -22, while the C4 plant, as is the case with maize and cane sugar, there we have a higher percentage, a higher value. So there are different ranges, and we know from literature that Matteo, there was an issue with the connection. We didn't get what you said. We were talking about the botanical, vegetal origin, which has an effect on the variability of the isotope ratios in C3 plants, as is the case with fruit trees and vines. The range is lower there. We have negative values between -22 and -33, while the variability of C4 plants, including maize and cane sugars, that have less negative percentages. In between these two ranges, we have sea phytoplankton, including crustaceans, where the value is approximately -15 per thousand, not percent, but per thousand. Nitrogen is heavily impacted by the trophic level. So we move from phytoplankton to increasingly bigger fish until we get to carnivore fish. And there we have a change in the isotope ratio. In our study, our assumption or hypothesis was that the chitosan from crustaceans were different from the fungal one due to the different origin, the different source. The crustacean chitosan is taken from the exoskeleton of crustaceans that come from phytoplankton, and in turn, and there we have characteristic features. If chitosan with this origin is considered, then the value is -20 per thousand. Then chitosan from fungi, it is obtained from the fermentation in a broth, which includes cane sugar, and that is a C4 plant. So the characteristic value is that of carbon-13. There we expected a much less negative value for chitosan. In addition to that, we tested whether the deacetylation process had an impact on fractionation. What is isotopic fractionation? It is an alteration in the isotope ratio between the heavy and light isotopes due to temperature, for instance, or the presence of acids as external phenomena. Our study confirmed what literature tells us, meaning that in the passage between exoskeleton, chitin, and so on and so forth, we have no alteration of the isotopic ratio, meaning that the reference value that we have in the exoskeleton of animals can be an index of what we find in the chitosan obtained from the exoskeleton of crustaceans. Here come the results. These are the results of the first study that we performed. All the samples of animal origin confirmed to have a much lower value when compared to the fungi, where values are less negative. And that indicates that the isotopic ratio or the isotope ratio is a good way to discriminate between the two origins, while nitrogen in this case is not useful to discriminate. In the second part of the study, we considered oxygen and deuterium. We know that the isotope value of ocean water is very different from groundwater after precipitation. That is due to the fact that the ocean value is approximately 0, while due to evapotranspiration, there is an evaporation of the lighter isotope, which means that in the clouds we have a vapor which from an isotopical viewpoint is lighter when compared to ocean water. So this water is lighter, it tends to fall with rain onto the ground again, and that feeds the groundwater, which has a lower isotope value, which is -5 per thousand. And you see that highlighted on the slide. This is important because it could be used as a discriminating index to distinguish between the crustaceans living in the ocean, where the isotope ratio is higher, and fungal origin chitosan, which is obtained in a broth which uses groundwater where the isotope value is lower. The results confirmed this. So you see that the samples of fungi invariably have lower values of oxygen and deuterium when compared to the animal samples, because crustaceans are in ocean water, in sea water, and the value is different for them when compared to the groundwater, which is what we find in the fungal chitosan. All parameters were then assembled and put together in a PCA, in a principal component analysis. You see there that carbon, oxygen, and deuterium permit to distinguish and discriminate between the two origins of the product. We also performed a validation round with a reclassification. You see squares and circles, which are empty, which indicate the validation samples. And they all fall within the variability range of the products, which are typical for the two origins, which again tells us that the method can be validated. What do we still need to work on in the future? What remains to be done? Well, we certainly have to implement the database, meaning the number of samples, so that we can define a legal limit for the fungal product. We must develop a method that allows to separate chitosan in complex matrices in order to test commercial products, because to date we only make our tests on pure products after washing it in water in order to eliminate organic acids that can be present, while in complex matrices, which include bentonite, we will need to separate chitosan in order to avoid altering the final isotope ratio. And I also am a member of a specific team that works on methods, and I know that we have to make the method official by including chitosan in the OIV monograph. I thank you very much for your attention. I thank the organizers, and I thank Per Domini IOC for inviting me today to take the floor. Thank you very much.